Hey guys, so we're back with the next video today. I'm Adi,
And I'm Sudhi.
and so the topic for today is text summarization.
Hmm.
So what is text summarization? When we come across like a huge paragraph or huge documents, we don't want
So
to read
interested
it,
to
right?
read it. Yeah.
Humans are becoming lazier day by day,
Yeah.
and so we just want a summary of the entire read. So how can we do this? We don't want to read through this, and we just want a summary directly. So this is really popular among like news stories and stuff.
Hmm.
We don't want to read an entire newspaper. Like
Yeah.
so,
Yeah.
what we do is we can come up with a summary of the entire document.
Hmm.
This is actually you can test this. This is an application about this with the news documents. Like is actually there's an app called In Charts. What it does is when you give it an entire news article, it summarizes the entire article into 60 words, exactly
Hmm.
60 words. It's an app, you can download it, it's pretty interesting and cool. So that's what we're trying to do here. We don't want to read the entire document, so we want a summary of it.
Hmm.
Um, so, what are the steps involved, Sudhi?
So there are three main steps involved in text summarization. So basically, first one is key phrase extraction.
Mm-hmm.
So we have already seen some of the applications of key phrase extraction. It could be bag of words, could be TF-IDF, and you might have also used it for your project one post tagging. So these are all some of the algorithms for key phrase extraction.
Mm-hmm.
Topic modeling, we will be looking into topic modeling in the coming lectures with clustering and stuff.
Mm-hmm.
And last but not the least, annotated document summarization, which we will be concentrating in today's lecture.
Okay.
So, yeah.
So, what is annotated document summarization? This is the main summarizing part, right? So,
Mm-hmm.
and there are two techniques to do this summarization. One is extraction-based technique, is a extraction-based technique, and the other one is an abstraction-based technique.
Yeah.
So, an extraction-based technique is when you're given this entire huge document,
Mm-hmm.
and you are literally like taking key phrases or sentences or words from the document and then combining them to give a summary,
Yeah.
which is way shorter
Yeah.
or way smaller than the entire document. With abstraction-based technique, what you do is the summary which you come up with is is an entirely new one,
Yeah.
where you may not find some sentences in the summary in
Mm-hmm.
your original document itself. It's more complicated. It's more time taking and whatnot. So we're not going to look into abstraction based today. We're just going to look into extraction based. So when we get into extraction based algorithms, there are two. One is latent semantic analysis and the other one is text rank. We're not going to look into latent semantic analysis there. It uses SVD and stuff.
It's basically bag of words and TF-IDF again, so
Right.
that's fine.
But we're going to look into that later again.
Mm-hmm.
The main one, the important one, is text rank. So what is text rank? Um, it it is it uses page ranking.
Mm-hmm.
I'm sure all of you have heard about this page rank buzzword a million times.
Google.
It's an
Yeah.
algorithm which Google came up with,
Mm-hmm.
and it uses Google uses this page rank in every Google search we do.
Yes.
So what is page ranking? When given a list of websites, each website may or may not lead to another website.
Mm-hmm.
So we come up with a matrix with every website n cross n, and so and this matrix consists of probabilities of each user going from one website to another website.
Mm-hmm.
So, and when we sort this, we come up with a ranking system. And so this is the page rank. When we convert this to, when we look at this from a perspective of text, instead of all these websites in this matrix,
Mm-hmm.
we're going to look into key phrases or words or sentences. And so the probabilities are going from one sentence to another.
Yeah.
And so what when we sort this, you come up with a text rank.
Mm-hmm.
And so what are the steps involved? So you can see that, so first we have these articles. We first combine all these documents to one. We split it into sentences. We all know what vectorization is. And so we come up with a similarity matrix,
Mm-hmm.
which how these sentences are similar, how they lead to each other
Yeah.
and stuff. And then we come up with a graph similar to this,
Mm-hmm.
which leads to another sentence and stuff. The
Yes.
nodes are the sentences here.
Mm-hmm.
And now we rank them. So based on this ranking system, we can summarize the entire document with the top ranked sentences. So now we're going to look into an
Example.
example.
So let's go ahead and all
Okay.
right. Now, so I have an example document here. It consists of 4 sentences, and Gensim library provides us with the summarization library, wherein you can either extract the summary of the document, which is the summarize algorithm, or the keywords of the document, keywords in the whole document, which is keywords. So let's look into how summarize works. So summarize takes in an input, which is the text document itself. So here I'm splitting the documents with the new line because there are 4 sentences basically. So I'm splitting it into 4 sentences, and the output I need to see it as a split sentences as well. So for a better view, so I've mentioned the split as true, and the ratio here is 0.5, which means that I need half of my document as a summary to my whole document.
Mm-hmm.
Yeah, itself. You can mention it as zero point 0.2, zero point 0.1, depending upon how big is the article and how much summary do you need.
Mm-hmm.
So summarize basically goes through all the steps that Adi just explained in the previous slide, and it's a pretty good function. It also gives since there are 4 sentences here, the output is just 2 sentences, and the sentence being the highest rated sentence. So this was an inbuilt function. What if you want to write your own function?
Mm-hmm.
How would it go? I'm just showing a prototype for a prototype algorithm here, but I don't have the exact algorithm because I couldn't find a better corpus to get the vectors for my data itself.
Mm-hmm.
So the first part is, as you have seen previously, it's text and splitting it into sentences, which means cleaning of the data. So here I'm cleaning the data with respect to each sentences and removing all the stop words. After removing all the stop words, here's my sentences, and all the sentences you can see it is split into. It is split into parts. And this is my key vector model, wherein you can actually get the vector form of each word or each sentences or the each key phrase. So this actually takes in the input of the corpus data, wherein you can get the vector for your words.
Mm-hmm.
Since I didn't have the corpus data, I tried to use the Google Vector -300 binary, which is a 3 gig data. You can try it, but you won't get the better result because it does not have better corpus with. Too many words to compare the corpus with. So the next step was to next step of keyed vector. Next step is to find the match with each word in your document with the keyed vector itself. So this part sums up the vectors sum inside for each word and stores it in a matrix here. And from this, we know that we find the similarity matrix from the previous slide. The next step was for similarity matrix. So we find the cosine similarity between one vector with all the other vectors and so on, which is n by n. And then Networkx provides us with the graph function, wherein we can create the graph function. Networkx is basically a huge library wherein it has all the graph algorithms, be it be between centrality, or do you want to find page rank, or do you want to find anything related to graph. Networkx is a library. So Networkx has a page rank algorithm wherein since we have converted all our text into vectors and created a graph, so it reads the numbers and it will throw out the rank for each sentences.
Mm-hmm.
And from there you can map each sentences with the rank itself and sort them in descending order. That means the top rank with a sentence with the top rank is your top summary.
Mm-hmm.
So this is the usual step that you follow with the text ranking using the PageRank algorithm. And yeah, if you can get a good library to compare the vectors, that will be a good one, and then you will get a particular idea of how the text ranking works.
Yep.
So this is it for the text summarization video.
Yep, and
And
we'll catch you in the
for the
next
clustering,
clustering.
text
Clustering
clustering.
is our next topic.
Yeah.
All right,
See ya. Bye bye.
bye.